Hello, welcome to Economic Dispatch Section 1, presented by Dr. Nit Petrax. In general, there are many types of generator. Some are expensive, some are cheap. Therefore, we need to perform economic dispatch to plan for each generator. How much real power it should produce to obtain the least total production cost. Suppose there are two generators supplying power at the same bus. These two generators are in operation for this hour. Generator G1 is cheaper. Its cost function is 1,200 baht per megawatt hour, whereas generator G2 is more expensive. Its cost function is 2,000 baht per megawatt hour. Load demand is 100 megawatt. If it is possible, we would like to use generator G1 to produce and supply all real power 100 megawatt and let generator G2 not produce at all. However, there are generation limit constraints. Generation output must be higher than 20 megawatt and less than 100 megawatt. Therefore, generator G2 must produce at least 20 megawatt and generator G1 should produce the rest of power requirement 80 megawatt. Total cost is 136,000 baht. If we change load demand to be 150 megawatt, even G1 is cheaper. It could produce only 100 megawatt. Let G2 produce the less power required, 50 megawatt. This costs total production cost 220,000 baht. Now examine another problem. These two generators supply power for load demand 200 megawatt at the same bus. G1 cost function is 1,000 baht per megawatt hour, whereas that of G2 is 1,500 baht per megawatt hour. Try to dispatch this problem and calculate total production cost. G1 is cheaper, but it could produce only 150 megawatt, whereas G2 must produce at least 50 megawatt. This results in total production cost 225,000 baht. Can you expect what happens if load climbs up to 220 megawatt? Let's think about it. 1, 2, 3. The answer is G2 will produce the addition of load 20 megawatt since G1 has already reached its upper limit. Now we put one more constraint, transmission line constraint. Power flow in transmission line must not more than 50 megawatt. Even though G1 is cheaper, but it could not produce more than 50 megawatt because of line limit. G2 must produce the rest power 100 megawatt to supply the load 150 megawatt. Let's examine another problem. There are two generators which supply real power at different buses linking with a transmission line with its limit 100 megawatt. Load 200 megawatt at bus 2. Try to perform economic dispatch and calculate total cost. G1 is cheaper, 1,000 baht per megawatt hour, but it should produce only 100 megawatt to satisfy line limit. G2 should produce 100 megawatt. The total production cost is 250,000 baht. Let's think further. What should we do if we have local load at bus 1 120 megawatt? 1, 2, 3. The answer is P1 is 150 megawatt, P2 is 170 megawatt. Do you know the reason why? I'm sure that you can find the answer by yourself. We perform economic dispatch with the objective function, minimize total production cost, while satisfying power balance constraint. At any time, power supply must equal to load demand. In case of two generators, P1 plus P2 should equal to load demand, and power from each generator must be within the generation limit, lower limit, and upper limit, and transmission line constraint should be taken into consideration. Do you have any questions? Someone may think why we must perform economic dispatch to accomplish objective minimum total production cost. Let's think together a few seconds. 1, 2, 3. The answer is the cheaper power plants. In case of the same type of power plant, would be more efficient. It means that they use less input to produce the same amount of output, less fuel, and less environmental impact. In addition, high production costs will reflect people in electricity bill. The next question: what should we do if it could not satisfy all constraints? 1, 2, 3. There are many possible solutions. Rescheduling power plants, starting more power plants, or shutting down some power plants, or load curtailment, etc. What will happen if power plants produce higher than their upper limits? Let's think together. 1, 2, 3. Their efficiency will reduce dramatically, resulting in much more fuel consumption, and consequently reflecting in higher costs and higher pollution emission. The last question: are there other constraints? Yes, there are many other constraints, such as environmental constraints, fuel constraints, ramp up and ramp down constraints, etc. This content is a simple economic dispatch introduction to basic concept. Thank you for your attention. Please stay tuned for more clips.